All right, you can set your pencil down for a second. We're doing section 32.2 today. I want to kind of give you an overview of what the section is going to look like before you write anything down. So just look up here. Here I have a circle. And we've learned before, if this is 90 degrees, that this is 90 degrees. And if I have this circle, and this is 90, this is also 90 degrees. It's a fourth of the whole 360, so 90. If I were to get a tape measure out and measure this, and this, would I get the same measurement with a tape measure? Is this length the same amount of inches as this length? No, they look way different. Even though they're both 90 degrees, they're going to be different lengths. Or if I do this, let's see if it'll work. Ooh. Hard to make it even. Well, now they kind of look the same. See how large that arc is now? Even when I make it bigger, it's still 90 degrees, but the distance it covers is different. So that is what we're going to talk about today. If I were to get a tape measure out and measure this, it may end up being like 11 inches, and this may only be like 5 inches. Today we're doing arc length, not just how many degrees is it, but how long is it? What is the length in inches, feet, or centimeters, something like that. Let me give you another idea. You don't have to write this down either. Let's say I know that the circumference of this whole circle is 80. The whole circumference is 80. Think about if you could figure how big this arc is if the whole thing is 80. The idea is how big the red arc you think might be if the whole circle is 80. 20, that's right. How'd you get that? Right. I have 90 degrees, and that I could do 4 times. So if I have a fourth of the whole circle, a fourth of 80 is 20. That's exactly right. This would be 20 meters. Now, what if I give you something like this? I told you that this angle is 112 degrees and the whole circumference is 317. You see how that would be a little bit harder to do in your head? Right? It's the same idea. So we're going to study how to do these harder ones. But I wanted to give you one you could kind of do in your head first to get an idea. Here's sort of how it goes. 90 degrees is a fraction of the whole degrees, which would be 360. Well, 90 over 360 is a fourth, just like what we were thinking. Just like this arc length is a fraction of the whole circle, 80. So if I were doing this one over here, the degrees I have are 112 out of, what's the total choice for degrees? 360. What's the total circumference outside? 317. What fraction do I have? That's what I want to know. This is how we're going to go about solving it. Figure out what fraction of the circle you have, and that will be what fraction of the whole outside you have. All right, grab your pencil if you would. There is a box for formulas. We're going to take up about half of the box to write this formula. It's in what we call a proportion, or 2 equal fractions. First thing we need to know is how many degrees do we have? In the example I gave you, it happened to be 90, but it won't always be 90. So look at how many degrees you have. That will always be a fraction of the total degrees, the whole circle, which is going to be always out of 360. Then I will be able to find the arc length Let's draw a picture of arc length. So draw a circle. Pick any angle you want. This outside is the arc length. Do we see how that is a fraction of the whole circle, which we call circumference? Okay, you can set your pencil down. I want to demonstrate one other thing. Let's say, using the same picture, let's say that the area of the whole circle was 200 meters squared. The area of the whole pizza, 200 meters squared. I want you to think about how much area this slice covers. Raise your hand if you have an idea. How much area is that blue slice? What do you think? 50. Can you just take a fourth of that? Yeah. Though this slice is a fourth of the whole pizza. So a fourth of 200 is 50. Again, if I gave you a more difficult one, let's say this is 32 degrees and the whole area is 411. That would be harder, but it's the same idea. I want this fraction of the whole pizza. Here's sort of how it works. Again, the degrees that I have, in this case, 90, out of the total, 360. That's the same fraction that this piece, which we call, is a new vocab word for today, I'll have you write it later. That sector, that slice of pizza, is a fraction of the whole area of the circle. Pick up your pencil. We're going to write our other formula for today. It starts the same. The degrees we have over the total degrees, which is out of 360. Then we're going to write the new word sector. A sector is like a slice of pizza. It's like a fraction of the whole area. Let's draw a picture. That's a sector. And that is a fraction of what goes on the bottom. It's a fraction of the whole area, the area of the whole circle. So I just put area of the entire circle. Questions on the formulas, how they work, anything? Okay, let's look at this first question. It says, number one, find the indicated measure, and they want you to find arc length of AB. This is the arc length of AB. Not 88 degrees, but how many meters is it? That's what we want to know. Well, I know I'm going to use this formula because it has arc length. So if you would just recopy the formula. Let's fill in what we know. We do know the degrees. There are 88 degrees in this slice always out of 360. The arc length is what we don't know. So I'm going to call that what we're trying to find, arc length. Unfortunately, I also don't know circumference. If I just put C for circumference, I have two variables. That's not good. Since I know this is what I'm trying to find, that must mean there's a way for me to find this other unknown, circumference. Let's think about yesterday. We learned about circumference yesterday. Can anybody tell me the formula for circumference? A lot of you should. Very good. Please off to the side so that part's not getting messy. A little bit off to the side, right? Circumference equals 2 pi r. Okay, right, 2 pi, and look at your picture. The radius was 2. So without a calculator, 2 times 2 is 4. So 4 pi. We have just figured out the circumference. We didn't know what to write there, but now we do. It's 4 pi. If you want to do the decimal, that's your choice. I think it's easier to just write 4 pi. I now only have one variable. I can solve this by cross multiplying. We've done tons of cross multiplying. You guys are good at this skill. Go ahead. Multiply across. Then put an equal sign. Then multiply the other cross. Yep, we're all getting our calculator and we're typing in what we need to. So if you ever have two unknowns, you're like, I don't know the arc length, I don't know circumference, likely you'll be able to figure out one and only have one variable. Questions on this one? We're skipping B. Let's look at number 2. Find the radius. Well, where are we going to start? Because neither of these formulas up here have radius. There's a radius in the circumference formula. There's a radius in an area formula. Well, what does this picture have to offer us? Look right here. We know a degree. That's not helpful. They both had degree. This is an arc length, 9 meters. So because they give us arc length, I would choose that formula. Let's recopy that formula. The degrees are 100. The arc length is known. That's 9 meters. You can just write 9. We'll label things at the end. I am going to be able to find C circumference. I would leave it as C. X is not wrong. But this way, when I'm done, I know I have the circumference. And then I'll just use what we learned from yesterday to find the radius. If we call it X, we might think we're done. Call it circumference. All right, multiply across. If you were to circle that answer, I would give you maybe half the credit. Done a lot of good work. Think about what you have and what you need. You have the circumference. You want the radius. Let's write our circumference formula from yesterday. Circumference is 2 pi r. We just found circumference, so we plug that number in right under C. To find r, divide by 2 pi. Don't forget your parentheses. .16 meters. Let's talk about labels for a second. When you label a radius, that's going to be in meters or feet or inches, whatever, but meters. When you do diameter, that's still meters. When you do circumference, that length is meters. When you do arc, that's meters. When you do a sector, that's an area. That would be meters squared, just like area of the whole circle is meters squared. So meters, inches, feet, whatever, for radius and diameter and arcs and circumference. The only ones that are squared are sectors, because they're a chunk of the area, and the entire area would also be squared. Questions on labels or this problem? Okay. We're on to 3A. Find the area of the sector formed by angle RQS. RQS is this sector right there. So they already have it sort of highlighted for you. Based on the directions, you know what formula to pick. Area of sector. Let's pick that formula. Okay, let's fill in. The degrees are 63. This sector is what they're asking me for, so that's X. The area of the circle is not told to us. I already have an unknown. That must mean I can find the area myself, which we can. Let's see. Trevor, I'll take the area formula if you can tell it to me.
Pi A is equal to pi r squared.
Very good. Pi r squared. From the picture, our radius is 5.
Sorry to interrupt. I have donuts for you. Thank you so much.
My check's in Promises mailbox, which is very full.
Perfect. Thank you.
5 squared is 25, not 10. Careful. 5 squared, 25. So we don't have an unknown. We do end up knowing the area of the circle, 25 pi. All right, we only have one variable. We are ready to multiply across. What do we think? Not too bad? Two things. One, if you are pretty comfortable with this and you would rather, instead of writing area of the circle here, if you would rather write pi r squared, because that's the formula, that's okay to do. Just like in this formula, if instead of circumference, you want to write 2 pi r, I'm okay with that. Let's talk about memorizing formulas. We'll have to know these, but I want you to try to not just memorize. Think about the parts you have. So both formulas start with degree over 360. Now think about the pieces. Arc length. This is a fraction of, well, let me just keep going, the circumference. That's why they go together. The arc is the outside. The circumference is the outside. Just like over here, a sector is a part of the whole circle's area, which is why they go together in a fraction. Hopefully, they're not too difficult to remember. All right, I'm going to give you some time to try B on your own. Try not to look up until you're done. You can do it. It's just like A. Yeah, put your phone in the thing, please. Oh, you just put 81. 81 pi is your area. Because you have neat work, that would cost you like half a point, so it's not a big deal. It's a big deal in terms of your answer. Your answer may be way off, but your work is close. Your answer could be. Questions on this one? Let's see. 74.93 feet squared is the area of the sector that's shaded. Yeah.
How did you put the 81 pi and 106 into the calculator?
So I just typed it kind of like it looks, 106 times 81 pi to get that 26973. All right, we only have one left. Directions are important here. Find the area of circle C. We want the entire area. which must mean that this information is not the area of the circle. That wouldn't make sense for them to ask us and then put the answer there. So that must mean that's the area of this sector that it's right next to. That given information is the sector area. Let's write our formula, make sure 22 goes in for the sector. Yep. Yeah, the more proportions you do, you're like, ah. Pretty quick one. See if your answer makes sense. If your answer is smaller, that doesn't make sense. If the area of the whole circle is smaller than the little slice they gave you. You have to what? Oh, no, because the sector is already a part of the whole area. So you have to add that. Alrighty. Let me go back to the formulas for just a minute. They're kind of messy here. We talked about how to sort of think about the formulas instead of just memorize. The only other two that we have from yesterday are circumference, 2 pi r, and area, pi r squared. Remember, they both have an r, they both have a pi, they both have a 2. One is times 2, one is squared. Usually area is bigger, and when we square things, they get bigger than just multiplying by 2. It's kind of maybe a helpful way to remember that. Your homework, I mentioned it's kind of long, but we're going to have a work day tomorrow. So you're going to try to get the page done today and maybe 2 pages done in class. There's some tricky ones. There's also some basic ones. We did like 5 more basic ones today. There'll be a lot that you can do on your own without help. There's plenty that you might want to ask about. Try to think about it. Don't just raise your hand after looking for 2 seconds. I think you might be able to get farther than you think you can. I would like to talk about 1 through 3 because I think we'll all kind of have a similar question. On your homework, 1 through 3. The equation of a circle is given. Find the circumference of the circle. Write the circumference in terms of pi. It's been a while since we studied the equations. That was actually back in activity 27-1, I think. If you recall, let's look at number 2. From an equation alone, you were able to find the center and the radius. Can someone recall what the center would be for number 2? There you go. -2, 3. Yes, opposite of what you see. Opposite of what you see. That's the center. Jared, do you remember how to find the radius? 3. It's always, remember this was r squared. So the square root is 3. Now let's think about the question. Find the circumference. I don't need the center for the circumference. I just wanted to talk about that because this is something that would come up on a final. So it's good to recall that information. If I want to know the circumference, well, I have my formula, 2 pi r. So the radius is really the only number I need. Turns out to be a pretty quick question. 2 times 3 is 6. they wanted us to leave it in pi. So 6 pi, we don't know the units. So you don't have to find the center, but just to recall it for the final. Find the radius, find the circumference. All right, try to get at least one page done tonight. Do more if you want. Just don't tell yourself, oh, I don't have homework tonight, because then you're going to have a ton tomorrow, perhaps. So get a good start on that. Let me know what questions you have as you're working. I'll be right there. Oh, good question.